Begin looking at section 6.1, we're going to start talking about ratios and proportions, which will eventually lead into talking about triangle similarities. So, again, we're just kind of laying the groundwork here for chapter 6. You should already be familiar with these ideas. Most of this is algebra review, so we'll just kind of buzz through these notes, and hopefully be pretty straightforward for most of you. So, example 1 says simplify the ratio. Be sure to convert to same units before simplifying. Okay, so again, you want to have the same units before you simplify down to a ratio. Remember, a ratio is simply a comparison of two numbers. Okay, essentially is what it is. So when I look at this first ratio, I can rewrite this as 76 centimeters over 8 centimeters. And generally, what we're going to do in this class is we are going to look at ratios as fractions more than anything, because those are the easiest types of ratios to use. So the centimeters essentially cancel out. And so I have 76 over 8. And when I reduce that, I know that 4 goes into 76 19 times, and 4 goes into 8 2 times. There's my ratio, 19 to 2. In part B, I have to convert first. Remember, 4 feet, there's 12 inches in a foot. Or what you could do is you could say, okay, this is 4 feet, and I know that 24 inches is 2 feet. So now your feet cancel. 4 over 2 is the same thing as 2 to 1. Okay, we would not just say 2. We're looking at a ratio. It's a comparison of numbers, so we would leave it as 2 over 1. We would not simplify that down to just say 2. Part C, I'm going to rewrite that as 4 meters over 8 meters. The meters cancel. I'm sorry, 18 meters. And then I know that 2 goes into 4 twice. 2 goes into 18 9 times, so the ratio here would be 2 to 9. Again, I'm just going to kind of keep buzzing through these. Part D, 33 yards to 9 feet. Okay, there are 3 feet in a yard, so I know that 33 yards, and then I have 9 feet, which is 3 yards. Because again, 3 feet in a yard, so 9 divided by 3 is 3 yards. The yards cancel. 33 over 3 is 11 to 1 is my ratio. Part E, they're not the same units yet. Okay, so I'm going to divide the 400 by 100 to convert that to meters. So you get 4 meters over 10 meters. Okay, the meters cancel. 4 over 10, divide both of them by 2, so you get 2 over 5. So 2 to 5 is your ratio. And then finally, $36 over $9 reduces down to 4 to 1 is your final ratio. Okay, example 2 says Josh is painting barn doors. He knows that the perimeter of the doors is 64 feet, and the ratio of the length to the height is 3 to 5. Okay, so I know the length to the height is 3 to 5, and so when you're trying to apply these ratios, all you're going to do is you're going to use the ratios and throw a variable on them. So just throw x on them. So in other words, call this 3x, call this 5x. And so I know what the perimeter is. The perimeter of this rectangle is going to be 3x plus 5x plus 3x plus 5x. Okay, so 3x, 5x, 3x, 5x. And then you just plug in what you know. They told me what P is. They told me P is 64 feet. So 64 equals 5, 10, 16x. Divide both sides by 16. So the value of x here is 4. The task is find the area. Once I know x is 4, I can plug it in and figure out this guy is 12 and this guy is 20. And so the area of the rectangle is base times height, which is just 12 times 20, which is 240 square feet. Okay, 240 square feet. Part B says the perimeter of a rectangle table is 21 feet. The ratio of its length to its width is 5 to 2. So again, same idea. Call this guy 5x. Call this 2x. 5x. 2x. Okay, task is find the length and the width. So I know I'm using perimeter because they told me right here I have the perimeter. So P equals 5x plus 2x plus 5x plus 2x. I know what P is. It told me that the perimeter is 21 feet. And that equals 24x. I'm sorry, not 24. 5, 10, 12, 14. So 14x. Divide both sides by 14. X is equal to 21 over 14, which when you reduce it down is 3 to 2. Okay, so x is 1.5 or 3 over 2, same thing. Part C says the area of a rectangle is 4,320 square feet. It says the ratio of the width to the length is 5 to 6. Find the length and the width. Okay, so again, length to width. Doesn't matter if it's proportional or not. Okay, so now I'm looking at area. The area of a rectangle is base times height. They told me that A is 4,320, and then 5x and 6x makes 30x squared. Divide both sides by 30. So x squared equals, let's see here, zeros will cancel. So you have 144, and then square root both sides. So x equals plus or minus 12. Okay, but clearly in this example, it doesn't make sense to consider the negative root. So your answer is just positive 12. Okay, and so once I know that x is 12, I plug it back in, find this guy to be 60. Make sure you have your units, so 60 feet. And 6x would be 6 times 12, which is 72 feet. So that's how we're going to use these ratios to apply them to certain problems. Example 3 says the measures of the angles in triangle BCD are in the extended ratio of 2 to 3 to 4. Find the measures of the angles. Okay, now one thing you need to know that we haven't covered directly is that the angles inside of a triangle add up to 180 degrees. Okay, and so once we've identified that, then we know that this angle, and this angle add up to 180, and since they're in this ratio, we'll do the same thing we've been doing. We'll just call this 2x, 3x, and 4x. And so now I know that when I add 2x, 3x, and 4x, those three angles have to add up to 180 degrees. So when I simplify this, I get 9x equals 180. Divide both sides by 9, so x equals 20. And so the task was find the measures of the angles. Well, 2 times 20, this angle is 40 degrees. 3 times 20, this angle is 60 degrees. And then finally 4 times 20 tells me this guy is 80 degrees. And so that's how we would find the angles in a triangle. You can pause the video and try part B on your own here. It's the same exact problem. So you're going to have 1x plus 4x plus 5x equals 180. Add them up, you get 10x equals 180. X equals 18. Once I know that, I plug them back in. So the first angle is 18 degrees. The second angle is 18 times 4, which is 72 degrees. And the third angle is 5 times 18, which is 90 degrees. So we're actually looking at a right triangle here. Okay, so nothing too crazy though. The cross products property is just saying that when you have two ratios that are equal, cross multiply. Okay, so A times D equals B times C. You've known that. That's Algebra 1 stuff. Okay, so example 4, we're solving proportions. I'm going to buzz through these pretty quick, so if you want to try them on your own and then just use the video to clarify and make sure that you did them correctly, that would probably be a good idea. So in part A, I cross multiply here, I get 4x equals cross multiply here. That's 48. Divide both sides by 4. X equals 12. In part B, cross multiply here, you get 3x. Cross multiply here, you got to distribute the 2, so you get 2x plus 2. Subtract 2x from both sides. X equals positive 2. Example C, again, just cross multiply. So 12 times 7 is 84, equals 2 times z. Divide both sides by 2, and that tells you that z equals 42. So hopefully you're finding these problems pretty simple. 5 and 4 makes 20, and then cross multiply this way, distribute the 10, so you get 10j plus 10. Subtract 10 from both sides, so you get 10 equals 10j. Divide everything by 10, j equals 1. Okay, j equals 1. So again, that's just a quick review on solving proportions. Now we're going to use that. So number 5, part A says Katie wants to find the total number of rows of boards that make up 24 lanes at a bowling alley. She knows that there are 117 rows in 3 lanes. Find the total number of rows of boards that make up the 24 lanes. Okay, so all you're going to do here is you're going to set up a proportion. We know that 117 rows makes up 3 lanes. Okay, and we know that the total lanes is 24. We got to find out how many rows that makes up the whole thing. Okay, and so now when you cross multiply here, you get 3x equals 117 times 24. Let me grab a calculator here. Okay, so 117 times 24 is 2808. Divide both sides by 3, and that tells you that x equals 936 rows. Okay, 936 rows makes up the entire bowling alley. Part B says a small gymnasium contains 10 sets of bleachers. You count 192 spectators in 3 sets of bleachers, and the spectators seem to be evenly distributed. Estimate the total number of spectators. Okay. What this really should say is estimate the total number of spectators that the gymnasium can hold. Okay. So I'm assuming that what they're wanting you to assume here is that the gymnasium is full, okay? And so the way you set this up is there are 192 spectators for 3 sets. How many spectators are there for 10 sets? Cross multiply, 3x equals 1920. Divide both sides by 3, so x equals 640 spectators. Okay. 640 spectators. Okay, the ratio of 2 side lengths of the triangle are given. Solve for the variable. All right, so in other words, example 6, they tell you that AC to AB, so AC to AB is 3 to 4. Okay, so in other words, you have AC, I'm going to rewrite this using fractions, so AC over AB equals 3 over 4. Plug in what you know. I know that AC they call x. So I have x over AB is 12. X over 12 equals 3 over 4. Cross multiply, you get 4x equals 36. Divide both sides by 4 tells you x equals 9 in part A. In part B, again, set it up using fractions. AB over AC equals 3 over 5. Plug in what you know. AB is x. AC is 25. Equals 3 over 5. Cross multiply, you get 5x equals 75. Divide both sides by 5. X equals 15. Okay, x equals 15. And then finally, to kind of summarize here and finish things up, and this is kind of, these last few examples is really where we're headed with this chapter. We have AC over BC equals 7 over 4. AC is 21. BC is 2x plus 4. Equals 7 over 4. Cross multiply, distribute the 7, you'll get 14x plus 28 equals, and then cross multiply the other way, 84. Subtract 28 from both sides. Whoops, 28. And so you get 14x equals 84 minus 28 is 6456. Divide everything by 14. So x equals 4. So again, I probably went through those notes rather quickly. If you got to go back and rewatch some parts of it, do that. If not, that's good too. Just bring any questions and concerns that you might have to class, and we'll make sure we take some time to clarify those things.